little while ago, I made a Minecraft board game from my Dash robots, and my Dash robots love this Minecraft game. But I thought to myself, instead of using my Dash robots, why don't I build a Spike Prime robot that could actually destroy these Minecraft characters even better? So, with the board game, the kids just distribute a few of these symbols and bad guys onto the board game wherever they like, and they roll a dice, and then after they roll the dice, they put the robot in the spot, and they've got to try and collect the two things that they've rolled. So you've got to drive over those two things, and then also get all the bad guys at the same time. So this is the goal of the game. Get the stuff, get the bad guys. I built a little robot. I like building little robots for this sort of thing because little robots can maneuver around mazes and obstacles a lot easier than big robots. So I got to work and I put a couple of motors onto a hub and I added some little wheels, and then I always plug my motors into C and D. I added a ball and socket, and that's a cute little robot. It's very level and nice and will turn easily because it's only got two wheels and a ball and socket. And then I attached another motor on top, which I would use later on for a weapon of mass destruction. So I put it together, plugged the weapon into port F, and then I added a beam on top to make that the spinning beam of death. I really wanted to make it so that when it saw the other robot, it would activate the weapon. So I put a distance sensor on the front, and the first stage was I needed to go forward 40 centimeters. When you make any sort of vehicle, you've got to set the movement motors, and you should set the wheel size as well, so it knows how many centimeters that it's going to travel, and then you can make it move forward 40 centimeters. After moving forward, I needed to turn right, and I anticipated the fact I might need to turn right a couple of times. So instead of just adding blocks to my main stack, I made another stack of blocks using my blocks, and I just called it right 90. So every time I wanted to turn 90 degrees to the right, I would use this stack instead of having to keep on re-eventing the wheel. So I set the yaw angle to 0, and the yaw angle is how many degrees the brick itself can sense in the gyro sensor. So you always set it to 0 to start with, and then you get it to turn until the gyro sensor senses that it's gone a certain number of degrees. If you select right 100, it means that the robot will spin on the spot. It's going to keep turning right until, it's going to wait until, we're going to use one of these little green operators, the one that says greater than 100, but we're going to put the little blue pill in there that says yaw angle, and we're going to make it say when it's greater than about 85. Okay, when it's greater than 85 degrees, we're going to stop turning basically. I've experimented with that number, and 85 is a good number because we want it to stop about 90 and say stop moving at the end. So every time I want to turn right, I can use that little block now in my blocks called right 90, and it does everything on the right there. After it turns right, I need it to go forward again. So we're going to grab another block from the movement menu, and we'll tap on the pink movement menu, get the top block, and make it go forward another 20 centimeters. Make sure it's always saying centimeters. And then we need it to turn again, but this time I think we need it to turn left. So we need to make another stack from my blocks for a left-hand turn. After it turns right, it's going to go forward, then we want it to turn left. So let's go back to my blocks and make a new block, and we'll call this one left 90. And this time it's going to be very similar to the right hand 90, except it's going to turn left. So again, we're going to set the yaw value to 0 at the start so it knows which way it's facing and how much it needs to turn. And then we're going to start moving left by using the pink block that says start moving left. And it's going to go left negative 100, which means it's going to spin in the opposite way basically. It's going to spin towards the left. Then we're going to wait until, but this time we're going to go for a yaw value that's less than, use an operator that says less than 85 this time, less than negative 85 actually. I'll just explain it with this other video that I made. When it's at a starting position, and we can get it to turn until the yaw, if we want it to turn left, it's got to be a negative reading. When it turns left, it measures negative degrees, and when it turns right, it measures positive degrees. So we could say, if we want it to go 90 degrees to the left, that means that it has to go past all these negative numbers, and we have to say when it's less than something like minus 89, then we want it to stop. Okay, for a right-hand turn, we have to say when it's greater than about 89 degrees, then we want it to stop. So to complete our left 90 code, we just need to put the yaw angle less than -85 in there and make it stop moving at the end. So every time we want it to turn left, we can just grab a my block that says turn left 90, and when we want it to turn right, we can grab the right one. So we're at the stage in our code where we need to add a left turn, so we go down to my blocks and add a left turn to make it turn left 90 degrees. Then after that, we have to go forward again. And since every square is 20 centimeters, we just need to go forward one square, which is 20 centimeters. So on the code, we need to go forward, go from the pink menu, move forward 20 centimeters, make sure it says centimeters. Then we need to make it turn right again. The robot needs to turn right. So we're just going to add our my blocks to turn right 90, which is pretty handy now we've made it. And then after we turn right, we need to go forward another 40 according to our diagram here. So we need to go forward one square, and then we need to go forward another square. So that's 40. And once we've added that code, we need to turn right again, won't we? Sometimes it's easier just to duplicate blocks than it is to grab new blocks. So we are just going to duplicate that and then change the 20 to a 40, and then it needs to turn right again. And then we need to go forward at the end just a little bit more and then stop moving. So after we add these final blocks, it will be time to test it. We're just going to test it without the weapon to start with, just to see if it all moves to the right spots. So here we go. Goes forward 20, 40, turns right, go forward 20, turn left, goes forward 20, turns right, goes forward 40, oh, and it hit the guy. But that's pretty good. I think it's going to work. So let's add the code for our distance sensor to be activated when it sees the bad guys. I've recently discovered that if you use a timer, then it helps activate weapons a bit better. It means that weapons don't go off by themselves sometimes if you use a timer. So in that first stack, I'm not just going to add this block at the bottom, which is fantastic. Add that block at the bottom, which stops and exits the program. I think that's really cool to exit most programs after it's finished. But go to the blue sensors tab and grab the one from the bottom of the blue ones that says to reset the timer. So there's a little block in the bottom of all these blue ones, and you can reset the timer, and that means in the background, when you start the program, a timer starts counting from 0. So get down the bottom of there, grab the one that says reset timer, pop it in there, and then to activate the weapon, we're going to make a new stack. And I just made it over here on the side, but it involves the timer as well. It says when the timer is greater than 1 second, then do this. Okay, so I used a little green operator with greater than 100, and I typed 1 in instead, and I put a little blue pill that says timer. So when the timer is greater than 1 and the sensor that's plugged into B is closer than 20 centimeters to something, then the motor, which I've plugged into F, is going to spin 5 times. And it's going to do that over and over again. So every time it sees something closer than 20 centimeters, it's going to start spinning. And I think that's much more interesting than just having a motor that spins and spins and spins and spins, but it actually does something when it gets close to the bad guy or bad mob. So that's the entire code right there. And maybe take a screenshot of that, and so you can use something similar if you want. But I've also added a bionicle weapon to my beam to make it a bit more interesting. Here we go, check this out, this is pretty cool. It's collecting the totem, and it's going to hit the bad guys, and it's going to knock them flying, because we don't like creepers and other bad mobs in Minecraft. Let's try that again. It's going to go forward, get the Enderman, get the Enderman, get the totem, turn right, get the zombie, turn right again, and get the bad creeper. Yeah. If you like this video, awesome. Here are some of my members. And they've been members for a while now, some of these guys. You can become a member too by hitting join on my channel, or even hitting the thanks button, give me a donation. But if you like this video, there's heaps of other ones here that you would really like. If you like Spike Prime, check these out.